This lecture introduces the learning module Earth Orbits the Sun, which is the section 2.2 in the book. The learning goals of this module are to know the difference between solar day and sidereal day, to understand and predict which zodiacal constellations will be visible in the night sky, to understand and explain the causes of seasons on Earth, and to understand and explain the consequences of precession of Earth's spin axis. The Earth orbits the Sun. The Moon also orbits the Sun while it orbits the Earth. The average distance between the Earth and the Sun is called the astronomical unit. It is about 150 million kilometers. Viewed from the North Pole, the Earth spins counterclockwise on its axis while it orbits the Sun, and also counterclockwise direction for its orbit. Consecutive sunrises mark a day. Originally, it was thought that this motion was the result of the Sun moving around the Earth. Now we know that it's due to the motion of the Earth about its axis. Daily motion is called diurnal motion. A solar day is 24 hours. Because of Earth's orbit around the Sun, stars aren't quite the same place 24 hours later. When the stars are in the same place again, one sidereal day has passed. Thus, one rotation with respect to the stars is 23 hours and 56 minutes. This is a sidereal day. One rotation with respect to the Sun is 24 hours, and this is a solar day. Viewed from above the North Pole, the Earth spins counterclockwise. As it spins, we have sunrise, daytime, sunset, and night. Consider that view from above the North Pole looking down. The Sun is so far away that the rays on Earth's surface are parallel. Half of the Earth is in sunlight and half is in shadow. The Earth orbits the Sun in a counterclockwise orbit as seen from the North Pole looking down. The Earth spins in a counterclockwise direction as seen from that North Pole. The Earth's spin gives us local time. The Sun rises at the location where the observer on its surface is just rotating into the region of sunlight. The Earth rotates towards the east. This is roughly 6 a.m. At local noon, the Sun is directly overhead. The Sun sets at a location where the Earth's spin is rotating the observer into the region of shadow. At local midnight, the observer is halfway rotated from sunset to sunrise. A convenient annotation is to draw a line from the Sun to the center of the Earth for local noontime. That is the time that Sun transits the observer's meridian line. This is called the Sun's culmination. Recall that the meridian line runs north to south through the zenith for an observer. A line drawn perpendicular to the local noon line and through the center of the Earth shows the locations for sunrise and sunset. A similar T-shape can be drawn for any celestial body that rises and sets. Figure 2.11 shows the celestial sphere with the ecliptic. The celestial equator is the Earth's equator projected onto the surface of the celestial sphere. The ecliptic is the apparent path of the Sun through the sky over the course of a year. The apparent gradual motion of the Sun on the ecliptic is due to Earth's year-long orbit around the Sun. The constellations the ecliptic runs through are called the zodiacal constellations, or the zodiac. This figure also shows the special points of the year of equinoxes and solstices. Although a solar day is 24 hours, the amount of sunlight varies throughout the year. As Earth orbits the Sun is seen against different constellations, the zodiac. The constellations are along the ecliptic. Earth makes roughly 1 degree of progress around the Sun per day, and this has two consequences. First, a sidereal day that is 4 minutes less than a solar day, and second, our view of the sky shifts by 1 degree per day. The constellations the Sun moves through during the year are called the zodiac, and the path that it moves along is called the ecliptic. The direction opposite the Sun shows the constellation that will be overhead at night. Since there are 12 zodiac signs in 12 months, roughly each month a new one is directly overhead at midnight. This image is not a star chart, it's a convenient depiction of the constellations of the ecliptic plane. The path the Sun makes projected onto the celestial sphere is called the ecliptic. The constellations along the path are currently called the zodiac constellation. Here's how the Earth is oriented. The constellation patterns are used only to represent the region of the sky the sun is on different days of the year. Winter in the northern hemisphere is when the Earth's spin axis is pointed away from the sun, and it has a snowflake marker. The Earth moves counterclockwise in its orbit around the sun as seen from the North Pole looking down. The markers show where the winter and summer solstices are and where the vernal and autumnal equinoxes are. On the vernal equinox, the sun's right ascension is very, very, very close to a star in Pisces called Omega Piscium. This star is also close to the celestial equator. The diagram can be used to approximate when zodiacal constellations will be visible at night. The zodiacal stars are so very far away that we can view the picture as if it were the sun and the Earth shrinking down to one small dot. The T now pointing to the sun on the vernal equinox shows the sunrise and sunset times on an imaginary tiny Earth at its origin. For the observer at sunrise, Sagittarius is directly overhead. Virgo is setting and Pisces is rising. For the observer at noon on the vernal equinox, Pisces and the sun are overhead, Sagittarius is setting, and Gemini is rising. For the observer at sunset on the vernal equinox, Pisces is setting, Gemini is overhead, and Virgo will soon be rising. For the observer at midnight on the vernal equinox, the Virgo is overhead, Gemini is setting, and Sagittarius is rising. Now in May, the sun is in Taurus. An observer at sunrise around 6 a.m. sees Aquarius overhead, Scorpio setting, and Taurus rising. The observer at midnight has Scorpio overhead, Leo is setting, and Aquarius is rising. And the observer at sunset around 6 p.m. sees Leo overhead, Taurus is setting, and Scorpio is rising. In summary, the Earth orbits around the sun because of the sun's gravitational pull on Earth. The period of the orbit is 365.256 solar days. The effects are a day measured by the sun differs from day to day measured by the stars by about 4 minutes. We see different stars at different times of the year. The sun has an apparent motion against the zodiacal constellations, which are called the ecliptic. The sun reaches a different maximum altitude and sets and rises at different times throughout the year. There are seasons. The equinoxes happen when the celestial equatorial plane crosses the ecliptic. While you're taking a time through this part of the chapter and through this learning module, there are some links to the Nebraska applets that help you visualize what's going on. First of these is the ecliptic zodiac simulator. There's also a sun motion demonstrator, which I highly recommend spending some time playing with. The celestial and horizon systems comparison. The paths of the sun applet. The obliquity simulator, showing differences in the change of the tilt angle between Earth's spin axis and the plane of the ecliptic. The celestial equatorial demonstrator, showing right ascension and declination. The coordinate system comparison, showing the differences between right ascension and declination on the left, the equatorial system, and the horizon system, showing altitude and azimuth on the right. We have the daylight simulator, showing how much of the Earth is in daylight at different years and times of the day. The Union Seasons demonstrator shows how the shadows and altitude of the sun at noon vary throughout the year at a particular place. The Rotating Sky Explorer, another one I highly recommend playing with. From this you can see different star patterns, which are the rise set, which are the not rise stars, and which are the circumpolar stars.